Assalamualaikum warahmatullahi wabarakatuh. So today our group will present about the temperature scalar for ideal gas and the absolute zero temperature. So our item to invent is the pan. So my name is Nomadiha Zira binti Abdul Hadi.
Hi, my name is Dina.
Hi, my name is Aisyah Umayyah.
And my name is Nurhani Natasha binti Abdurrahim.
Do you know how the ideal gas law relate to the temperature? So as everyone knows, ideal gas formula is PV equal to the nRT. So the temperature is directly affect the volume and pressure. It means when the temperature increase, so the volume and pressure also increase, depends on the system. Temperature must be measured in Kelvin so that the equation work correctly. And that's why scientists create the Kelvin scalar, which is starting from absolute zero, which is 0 Kelvin. Absolute zero is the point where molecule motion stop. So how to apply in this concept to the pan heating? When a pan heat up, the air inside and around it also heat up. According to the ideal gas law, when temperature increase, the pressure will also increase. Meanwhile, the volume will stay constant. The increase in pressure means gas molecule move faster and transfer heat more quickly to the pan surface. So a better contour in a pan is not just about the pan material, it's also about how heat move through the air and interact with the pan. So understanding this concept would help us to design pan that respond better to the temperature changes. So next, what key need are we meet? The key need we will be addressing is the need for precise temperature control and good heat distribution during cooking. This is because current pan may have hot spot or uneven heating, which can lead to the food burning or not cooking properly. So whose key needs specifically? The first one is home cooks. People who cook regularly at home always want a pan that heats evenly so their food doesn't burn or cook unevenly. Consistent heat makes it easier to get good result in every dish they serve. The second one is professional chef. In a busy kitchen, of course chefs is rely on the tools that perform reliably. Uneven heat can run a dishes. So, precision and consistency are essential for speed, quality, and repeatable outcomes. Third one is food manufacturers. Companies that producing packaged meal require exact temperature control to ensure every batch meet the same standard. Uneven heating can affect the taste, texture, and safety to the customer.
How often do people experience this problem and when? The problem of uneven heating is a daily occurrence for many people when cooking. This is especially noticeable when searing meats, making delicate sauces, or baking items that require even heat distribution. How big is the problem for users or customers? This problem can contribute to food waste. For example, uneven heating can lead to burnt or improperly cooked foods, resulting in waste and increased food costs. Other than that, it can waste times. For instance, inconsistent cooking temperatures can lead to longer cooking times and waste efforts. Moreover, it can show the energy inefficiency. For example, pans with hot spots might require higher heat settings, leading to increased energy consumption.
We move on to the question of what will happen if the need is not met. First of all, it can cause inconsistent cooking results. The food will not cook evenly and leading to poor taste and texture. Second, increased food waste. This can cause the burn or undercooked food will be thrown away, increasing food costs. The next one is frustration. Home cooks and professionals will experience frustration due to lack of reliable cooking tools. And the last one is safety concerns. Uneven eating can lead to the risk of burns and food poisoning due to improperly cooked food.
What is our unique approach to meeting this need? Our unique approach would be to integrate the concept of ideal gas behavior and absolute zero temperature into the design of the pan. We can achieve this by using materials with specific thermal properties based on the ideal gas law. Next, incorporating a temperature indicator on the pan that is based on the concept of absolute zero. Lastly, developing a method to ensure even heat distribution using the principles of thermal conductivity. What is our solution? First, material selection. We have to use materials that have high thermal conductivity and low specific heat capacity, such as copper or aluminium, to ensure fast and even heat distribution. Second, temperature scale integration. Incorporate a temperature scale that is based on the ideal gas law and absolute zero. This could be a digital or analog display that shows the temperature of the pan in relation to absolute zero. Third, heat transfer mechanism. Implement a design that ensures even heat distribution across the pan's surface, such as layered base or a heat conducting core. Lastly, insulted handle. Design an insulted handle to prevent burn and improve usability.
Next, do we have any technical issues to solve? Yes, we do. First of all, material properties. Finding materials that have the necessary thermal positive and are safe for food contact. Next one is heat distribution. Ensuring even heat distribution across the pan surface, especially when using different heat sources. The third one is temperature measurement. Accurately measuring the temperature of the pan using the ideal gas law and absolute zero as a reference. And the last one, the last technical issue that we have to solve is durability. Designing the pan to be durable and long-lasting. That's all from us. Thank you.